In examples 5 and 6, we need to verify these trigonometric identities. So for example 5, my eyes are being drawn right here to this more complicated side. At first glance, this is really hard for me to figure out, even if I change things into sines and cosines, how this would even work. I mean, I've got a sine plus a cosine in the bottom. There's not much we can do with that. This isn't 1 plus the tangent squared, so that's kind of stuck there. What I am noticing, if I look at the right hand side, that I eventually need a secant. So I think here, if I could only get maybe like sine over cosine, I don't know if that would work. Boy, that's a tough one. Well, I don't know. What's the secant? It's 1 over the cosine. So sometimes what can work is if you try to take the left side and just multiply by that right side. Sometimes that can work. Let's try that. So let's multiply the top by 1 over the cosine, and then I'm going to have to do the same thing here with the denominator. I have to multiply that by 1 over the cosine. So that's a good thing to try. If you're at a total loss, look at the right hand side. Maybe multiplying by that could simplify something somewhere down the line. So let's leave this top part, 1 plus the tangent of beta times 1 over the cosine of beta. And let's work with the denominator here. Let's distribute this out. So we've got the sine of beta over the cosine of beta. And this next term is going to be the cosine of beta over the cosine of beta. So now we've got 1 plus the tangent of beta times 1 over the cosine. And then we have tangent of beta here plus 1. Or, if you think about it, that could be also 1 plus the tangent of beta. Since that's in the denominator, that's being grouped, and now I see something that I can cancel out here. Sweet. So we can cancel these two out. I'm just left with 1 over the cosine. And the 1 over the cosine is the secant. So now, if you remember back to when we started the original problem, we've done a lot of stuff to the left-hand side, and now we've made it look like the right-hand side. So this one is good to go. Every step is fully explained, or at least each step is visible, what's happening, and this entire thing here, that is the solution. It's how to get to that point. Let's take a look at the one on the right, and this is example 6. Let's see if there's something we might be able to do with this one to help us out. So I think what I'm going to try to do here is I'm going to use this strategy of looking at the left-hand side, seeing if I can multiply that out. So like right now, this is not making sense to me. I don't know what I can do. It's already in sine and cosine. It's probably the most complicated side. Let's just multiply this top by sine theta, cosine theta, and the bottom by the same thing. So this is going to be 2 sine squared theta minus 1 times sine of theta plus cosine of theta, all over sine of theta minus cosine of theta times sine of theta plus cosine of theta. So here we're just multiplying by the numerator by sine plus cosine and the bottom by sine plus cosine. So we haven't changed the value of this, we're just multiplying by 1 here. In the next step, we can keep this 2 sine squared theta minus 1. We'll keep this sine of theta plus the cosine of theta. We want that to remain in the top if we want to try to make this look like the left-hand side. So sometimes it's better not to FOIL this out, just to leave it. Hey, you want it in the top anyway, so maybe we get lucky here. Maybe something will cancel out with the denominator. You'll notice here that this is going to be sine squared, negative cosine times positive cosine. That is going to be negative cosine squared. And actually, negative cosine theta sine theta plus sine theta cosine theta is 0. This is actually a difference of 2 squares here. So we're good there. You might think you could change this out for 1, but you can't. What you could do, though, is you could change the denominator out. We're going to leave this sine squared, and the reason why I'm choosing to leave the sine squared is because we're looking maybe for this 2 sine squared to cancel out at some point, so we want to probably try to leave it. And if I think about it here, I think this is equal to 1 minus the sine squared. And if we look at our Pythagorean identity, we can see that if we just let's see, if we just, what did we do here? We did cosine squared. So if we just subtracted sine squared, we'd be left with cosine squared equal to 1 minus sine squared. Reset the picture frame here for you. Alright. And so it's accurate to take this cosine squared out and substitute in 1 minus the sine squared. So this is still 2 sine squared theta minus 1 in the numerator, times the sine of theta plus the cosine of theta. In the denominator, we've got, let's see, well that's just sine squared minus 1 plus sine squared, so that's 2 sine squared of theta minus 1, and that's it. If you did this distribution here, this negative sign, and then combine like terms, you would find that that's 2 sine squared minus 1. Now we can take these and cancel them out. That's acceptable. So we've got the sine of theta plus the cosine of theta, which is what we were supposed to get anyways. Remember that when I'm doing these problems, I've done these several times before, and so the path that I am taking I've found out already, and it's not as easy as it seems right here at all. You may have to erase 10 different times and try something different. But each one of these examples, we looked at the right-hand side or the left-hand side, whichever side we're not working on, and we just multiplied the numerator and denominator by that same value. And that's something that can help you get unstuck in some situations.